Welcome to this new lesson on string algorithms that you are going to need for the AP exam. These are going to be generalized algorithms that you can use all over the place, and they're also going to be useful when we get to more complex data structures. And the rules that we learn here in dealing with strings are going to apply to those more complex data structures and give us a toolkit already ready to go for strings, arrays, array lists, and other things. Okay, so let's take a look at what we need to deal with. We're going to look at some code snippets here. The Repl.it is going to be linked down below so that you can open up the Repl.it and play with these anytime that you like. Fork them and mess around with them as much as you want. Okay, so here we are, and we have a simple algorithm. This is the basis for all the other algorithms dealing with strings, is how do we move through a string? So there are three components. First, we have the string itself. Then we're going to have, in this case, we're going to use for loops. For loops are the best ways to traverse strings because it has that built-in mechanism for counting through and moving along the string. We're also going to want to make sure that we have this less than sign. So I'm going to go ahead and take a screen cap of this so that we can write some notes on here. Some important things that we want to remember as I find my stylus is that it's really important to have the less than sign, right? The less than sign is going to make sure that we do not go out of bounds of length. So we find the length of the string, and this is going to be generalized for any string. We find that length, and then we're going to iterate. We're going to count up one at a time until we are one less than this. So this is going to help us avoid an out of bounds error. Avoid out of bounds. And if you recall from a previous lecture about this, we really want to avoid out of bounds. And this is going to print one character at a time. So if we want one character, remember that the difference between these two, the difference is the number of characters printed. Number of characters printed. Okay, so those are our critical pieces. We have the string itself, we loop through the string, and then we manipulate it. In this case, we're going to print one character at a time, but we can do any manipulation we need to by grabbing substring here of our original string. Okay. So let's jump back to the live code and take a look at what happens, predict what's going to happen. Well, we simply print out our string mountain biking rules, but that just looks like a regular print statement. But I can prove that it's a different print statement by changing this print to a println, or println, print line, however you want to pronounce it. And by doing this, now I'm going to print each character on its own line because I'm grabbing one character at a time. The difference between I and I plus 1 is one character. And there is mountain biking rules printed vertically. Now, what if I wanted to print two characters at a time? So I would change this to 2, but we might have a slight problem. Let's see what happens. Oh, it does print in this case, but then we get an exception down at the end. So we get a runtime exception because we go out of bounds at the end. So we need to, again, be careful about our out of bounds exceptions here. I plus 1. Okay, so that is traversing a string. Let's take a look at our next algorithm. So our next algorithm is a string for counting substrings. So let's go ahead and say that we want to count the number of E's in elephants eat peanuts. How would we do this? Well, first we need to create a new counting integer. And an integer is the data type, of course, because we want discrete numbers. And we want those discrete numbers so that we can count simply. We don't want to use a double. But it's also important that this count be outside of the loop. So that the count is persistent all the way through. Remember our scope of variables lesson where we talked about if we created a variable inside here, if our count is created inside the curly braces for the for loop, it won't persist. It will not go to the outside. Just like our int I is garbage collected down here. Let me use a different color here. Int I is garbage collected at the end of the curly brace. That's why we can't use I as a counter. We need to create a separate integer so that we can print out and count at the end. We can use a similar method here where we're finding one character. This is borrowed from our last algorithm where we're pulling out a single character, and now we're checking, does that character equal an E? Okay, so we ask this question. Remember that this resolves to a Boolean. And if that Boolean is true, we're going to add to our count. Otherwise, we're just going to keep looping through. Okay, look at that string. Elephants eat peanuts. How many E's are in that string? Go ahead and predict the outcome, and we'll run it here. Let's try running it again, see if Repl.it will behave. And it doesn't want to behave. What's going on, Repl.it? Let's try refreshing the page. Reload Repl.it. When in doubt, reload. My internet seems to be a problem. The one issue with Repl.it. And there we go. We get our answer of 3. Okay, so was 3 the number you thought? Remember that the capital E is a different character than the lowercase e. If we wanted to test all of the e's, not just lowercase e's, we would need to adjust this. We can use that to upper to count all of the e's. I'll leave that to you to try to figure out and see if you can count all of the e's here. Let's take a look at our next algorithm, concatenating strings. So concatenating strings means we're going to be adding on 2 strings and giving them a new thing, right? But what if we say we want to reverse a string? How would we flip a string around? Well, we can use this algorithm and concatenating strings to take a look at it. So let's take a look at some of the differences compared to our normal string traversal. So notice something different here. Instead of starting at I equals to 0, we're now starting at I equals to our string length. So we're starting at the end. And then we're going to work our way backwards by using I minus minus. So instead of starting at the front and moving forwards, we're going to start at the back and move backwards through the string. We also have to go at I minus 1 in front in our substring. And I is now the tail piece of data in our substring method. And we're checking that we don't go beyond 0 for our I. So that's our condition to make sure we don't go past 0. Then we're going to concatenate onto a new string. So you can't do it to the same string. You have to create a new string in order to do this. You can't just use the same string and try to flip it around within itself. You have to create a new string and then flip it around by going backwards and adding each character one at a time. Remember, the plus equals works just like plus equals for integers, but we're concatenating on strings. And finally, we can print out our new string. So what is the reverse of loop? Well, hopefully Repl.it will behave. And there we go. The reverse of loop is pool. Awesome. Let's move on to the next algorithm. So our next algorithm is staying in bounds using the modulus operator. Okay, so we need to talk about modulus really quick and about how we're going to use modulus to control and stay within bounds here. Well, these all ended up on top of each other. I'll have to move that around in the notes. Okay, move over, moving over, zooming out. Okay, so our modulus operator, if you recall, finds the remainder. And it's actually kind of really cool. Think about this problem. What if I gave you a string, ISSISSIPPI, Mississippi, okay? And I asked you to start in the middle of the string, I think that's the middle, and I want you to print from here forward, and then once you get to the end, I want you to loop around and print the rest of it. How would you do this? Well, you could create an if statement that checks the index, right? And if our index is less than the string.length, then you could do something. Otherwise, you take your index and you subtract the middle value, right? String.length. You can do something really complex. No need to do that. What we can do instead is we can say any value. If we take our index and if we modulate it by our string.length, no matter what the result of this is, it will always be in bounds. Remember that modulus returns the remainder. So if our index is bigger than the end of our string, we've modulated by the length of the string, we cut off, in a way, numerically, we cut off that and we get the remainder value. So let's say, for example, that our index let's give our index a value of 11, okay? And our string.length, the length of our string is 9. If we just tried to use index in a substring, we'd get an out of bounds exception. But if we modulus index by string length, if we modulus these two, so 11 modulus 9, what do we get? Well, we'd get 2. So now the resultant of this is 2, and index 2 is well within 11. So we would actually move to the other side of the string, which is exactly what we want. So let's take a look at this in the code. So in the code, we have exactly that. We have our string str4 is Mississippi. We're going to loop through it as we normally do. This doesn't change, but we create a new index value here. And the new index value takes I, finds the middle, right? And then it modulates by the length. Okay, so we're going to take a look at this. Oops, didn't mean to do that. Go back one. Take a picture. Here we go. So when we have this, right, we're taking the length of the string, adding our I, and dividing by 2. So we're basically finding a little bit past halfway and moving forward, right? A little bit past halfway and moving forward, a little bit past halfway and moving forward, a little bit past halfway and moving forward. And if we start at halfway and we keep adding up all the way to the length, we're going to go way beyond the end. So that's why we use the modulus here, prevents out of bounds exception. So this prevents out of bounds. And that is really handy. Then what we're going to do is we're then going to print out each character that we find at these new locations that we created of our index using our single character printing algorithm here. Okay, think for a moment, see if you can trace out this code and predict what our output is going to be. Did you get it? SSIPPIMISSI is our output. We start essentially in the middle. We loop all the way to the end, IPPI, and then we loop back to the beginning because this modulus protects our beginning. It protects us from going in to an out of bounds area. And we can even print this on a single line, or each character on a line, by doing our println and change it so it prints vertically. And that's our proof that we're printing one character at a time. And of course, we could add this to a concatenation, create a new string, and do something with it there. Okay, let's take a look at our last one here, removing substrings. Removing substrings is fairly similar to our reversal method. So if we look at this, or reversal algorithm rather, instead of simply counting, we're now going to combine this with our concatenation algorithm, and we're going to concatenate onto a new string. All right, let's go ahead and take a screen cap of this one. And here we can see, so we're adding in, we're using this from our counter. And we're using this from concatenation. And then we can replace in, so if we want to replace a string, this is replacement. But not really necessary, right? Depending on what the needs of our algorithm are, this may or may not be necessary. So these are all steps that we've seen before. We create a new string so that outside of our for loop, so that's persistent after our for loop. We concatenate into our string after we've checked to see if our character equals I. And if it does equal I, we have our not right here. And our friend not says if it's not equal to I, then we add it in. Okay? And go ahead and predict what the output of this will be, and we'll run it. So we run it, and it's Mississippi without the I's. Okay, so those are some simple string algorithms. They are also general algorithms that we can use all over the place using concatenation, using traversals, reversals. Take a look at these, play with them in Repl.it, and get them into your head so that you understand how they're working and how you can manipulate them to get the results that you are looking for. All right, I will see you guys in the next lesson.